Machine learning. You hear this term everywhere, right? In your news feed, in the apps you use every day. But what does it actually mean? How does a machine, well, learn? That's exactly what we're going to break down today. Let's get into it.
All right, so let's just jump right in with the biggest question of all. We're not talking about just programming a computer with a bunch of rigid if this then that rules. No, we're talking about teaching it to recognize patterns, make predictions, and even make decisions all on its own. I mean, how on earth do you even do that?
Well, it basically boils down to just three main ways. Yep, three core strategies that are the foundation for pretty much all the artificial intelligence we see today. So let's break down each one.
Okay, first up, we've got the most common and probably the most straightforward approach. I like to call this one the teacher's pet of machine learning. It's called supervised learning.
And the best way to get your head around this is with something we've all done, studying with flashcards. Seriously, imagine you've got a question on the front, and bam, the correct answer is right there on the back. That's it. That's the core idea right there.
The magic phrase here is labeled data. Just like your flashcards already have the answers, all the information we feed the machine is already tagged with the correct outcome. The model's job is to crunch through thousands, maybe even millions of these examples until it finally figures out the secret pattern that connects the input to the right output.
Now, this kind of learning is really good at two main jobs. First, there's classification. That's all about sorting things into different buckets. Is this email spam or not spam? A classic example. Then you've got regression, which is all about predicting a specific number, like how much is this house going to sell for? So one sorts, the other predicts a value. Simple as that.
All right, let's switch gears to our second type, which is a bit more adventurous. If supervised learning was our straight-A student, the teacher's pet, then unsupervised learning is the bold explorer, heading out into the wild with no map.
Here's a great way to think about it. Imagine I just dump a huge box of mixed fruit in front of you. You don't know the names apple, banana, or orange, but you can still sort them, right? You'd naturally start making piles. Okay, all the small red round things go here, and all the long yellow curvy ones go over there. You find the patterns yourself.
And that is the absolute key here. The model is working with unlabeled data. There's no answer key, no cheat sheet. The machine's whole job is to just dive headfirst into this pile of raw and usually messy data and discover the hidden structures and relationships all by itself.
And out in the real world, this is super powerful. One really common task is clustering, where a company might group customers based on their shopping habits to send them better recommendations. Another one, and this sounds way more complicated than it is dimensionality reduction. That's just a fancy way of saying simplifying complex data, like making a huge image file smaller without losing what makes it special. And that brings us to our third and final type. And honestly, this one might be the most dynamic of all. This is reinforcement learning. And I like to think of this one as the gamer, because it learns by, well, playing the game.
The analogy here is just perfect. It's like training a dog with treats. When you teach your dog to sit and it finally does it right, you give it a treat, a reward. If it just stares at you, it gets nothing. And through that process of trial and error, that feedback loop, the dog learns the best way to get the reward.
So, to get just a little technical, there are three big ideas. You have an agent. That's our learner, the AI. It operates in an environment. That's its world. And its entire goal is to figure out the best strategy to take actions that get it the maximum possible reward over time. This is the secret sauce behind some truly mind-blowing stuff. It's how AI programs mastered incredibly complex games like chess by just playing against themselves millions and millions of times. And it's also how a self-driving car learns to stay in its lane. Every moment it drives correctly, it gets a tiny reward, teaching it the best way to drive safely. So, we've seen the three main ways machines can learn. But how do we actually go from just an idea to a working model that does something useful? Well, it's a journey, a really structured process that brings these concepts to life. Think of it like a recipe. It all starts with data collection and preparation. You got to gather and clean your ingredients, and trust me, that's often the hardest part. Next is model selection, where you pick the right algorithm for the job. Then comes the actual cooking, training the model, and then evaluating it to see how well it performs. And finally, deployment. You release it into the real world to start doing its thing.
Phew, okay, I know that was a lot. We've gone all the way from flashcards to self-driving cars.
So if you're going to take away just one crucial thing from all of this, what should it be?
It really just boils down to those three analogies. Remember these and you've got it. Supervised learning, that's the student with flashcards. Unsupervised learning, the explorer sorting the fruit. And reinforcement learning, that's the agent learning from rewards and penalties, just like training a dog.
And that leaves us with one final thought. Understanding these methods isn't just some academic exercise. It gives us the power to ask the next big question. Now that we know the basics of how machines learn, the real challenge and the real opportunity is deciding what we should teach them to do next. What problems should they help us solve? Now that's something to think about.